Hello, welcome back to another episode of Math with Haas. You are watching Precalculus Season 2, Episode 17. We're continuing our investigation in trigonometry, and in particular the transformations of our sine and cosine graphs. So in the previous episodes we've looked at amplitude changes, vertical shifts, and period changes. Now we're going to consider horizontal shifts. So we looked at questions such as what happens if you take the sine function, multiplied it by some value. We looked at what happens if you take your sine function and what you plug into sine is multiplied by some value. And we looked at what happens when you take your sine function and you add some value to it. So the question before us is what happens if the thing you plug into your sine function is being added by some quantity. I don't know, we'll just call it, how about D? There we go, A, B, C, D. That's nice. Alright, so our question is, what is happening whenever you add or subtract some quantity, which we represent with a D? And so let's start like what we did in previous videos with a example. So suppose we have y equals sine of x minus about pi over 2. So just like what we did before, usually we want to make a nice table of values. So here we go, table of values, x, y. So if I recall the original sine graph we started, it looks something like this, where we start at 0, we have value here at pi over 2, pi, 3 pi over 2, and 2 pi. And up here at the top, that's a value of 1, and down here at the bottom, that's a value of negative 1. So if we start at 0, right, if we plug in 0, that's this point right here. Well, we have to take 0 minus pi, right? So if we think of sine of 0 minus pi, that's the same thing as sine of negative pi over 2. And we can use the fact that sine is a odd function, so that's the same thing as saying this is the negative of sine of pi over 2. Well, sine of pi over 2 we know is 1, so this has to be negative 1. Alright, and then when we consider, how about pi over 2? Well, if I plug pi over 2, I know it's the same thing as pi over 2 minus pi over 2 inside the sine, right? Sine of pi over 2 minus pi over 2, well, that's the same thing as sine of 0, which is 0. And if we plug in a pi over, or just a pi, right? So sine of pi minus pi over 2, that's the same thing as sine of pi over 2, which is equal to 1. By now I think I'm going to start seeing a pattern. Let's go ahead and use this nice pink. So here is, let's see here, we don't know. So when we are at 0, our new point here is at negative 1, and then our next point is at 0, and then we are over here at 1. You probably guess where our next value is going to be, right? If we plug in 3 pi over 2 in for x, we get 3 pi over 2 minus pi over 2, which is sine of pi. Sine of pi is 0, so that means we have to be down here. And then we just continue, right? So over here. So we get this as our graph. That looks kind of terrible. So what's really happening if we use a highlighter, so this is our graph based off the points if we continued the x values from 0 to 2 pi. When we look at our original graph in comparison, right, so We can't really see that color. We'll pick a different color. So when we compare our graph and we want to figure out what is one period, notice this right here would be one period. And in fact, this value out here would be 5 pi over 2. So how I got to 5 pi over 2, in case you're wondering, is, well, if I take pi over 2 and added a pi, or if I took 2 pi and I add pi over 2, that gives me 5 pi over 2. So 5 pi over 2 minus pi over 2, that's the same thing as sine of 2 pi, which is 0. So, in other words now, what we have going on is a horizontal shift. So, when I look at this value, we have a shift to the right. Now, this is going to be kind of confusing because we see we have this negative here, right? So we're going to come back to that in a moment. So suppose we had sine of x plus pi over 2. Okay. So here's x, here is y. So if I plug in 0, that's the same thing as pi over 2. Oops, I don't know what I was thinking there. If I plug in 0, that's the same thing as sine of pi over 2. Well, sine of pi over 2 is 1. If I plug in pi over 2, that's the same thing as sine of pi. Sine of pi, we know, is 0. If I plug in pi, it's sine of 3 pi over 2, so negative 1. And so we can start making our graph. So here's original. And here's our tick marks. So there's 2 pi, there's pi, 1, negative 1. And then here's our change. So here's the first point, second point, third point. So we get something that's going on like this here. So in this case, if we were to use our highlighter again, so right here would be negative pi over 2. That doesn't really negative pi over 2. Let's fix that. There we go. So in this case, if we wanted to look for where's the one complete period, here it is. So we'll come back to that point now about the minus sign. So when we compare both of these graphs, right, here we had a minus, here we had a plus. The key takeaway is this. You see, when we see the negative here, we really actually want to think of that d value as being positive. So remember we said what happens when we have x minus d. So reality is we have a minus sign right here. That minus sign is taken into account right here, which means that our d value here is actually going to be positive. So when d is greater than 0, we are going to have a shift right of d units. But when we have the plus over here, let's make a box here. So when we have a plus there, that's like this situation when you have y is equal to sine of x minus a negative value, right? Because sine this is the same thing as x plus d, right? So in other words, in this situation here, when you see this plus sign, you need to think of d actually being negative, and you have to shift left d units. So this is one of the most confusing things I think about these graph transformations, is the fact that when you see this negative sign, you automatically want to think, well, I have to move left. Whereas in reality, you need to think, no, d is actually positive, and so I shift right. And when you see the plus sign, you have to remember, well, it's actually going to have a negative d value, so you shift left. The key is remembering that, as I highlighted here in green, is that we've already took into account one of the negative signs. Okay, so here that plus sign is actually a double negative. So we want to summarize our results now, because we've now taken into account all of the transformations, and that's super exciting. So, summary. If y is equal to a sine of b of x minus d plus c, the absolute value of a is going to equal the amplitude. The period is going to equal 2 pi divided by b. Let's see here. If c is positive, shift, that doesn't look nice, shift up c units. When c is negative, we shift down c units. When d is positive, just remember our caveat before, we shift right d units. And when d is negative, we shift left d units. Now keep in mind, when we have our caveat for our d variable, just keep in mind that when you see the plus sign here, that means it's actually negative, and when you see the negative sign, as in right here, that means it's actually positive. So that's our caveat we need to remember. And then we also need to keep in mind, if a is negative, then we have a reflection across the x-axis. And similarly, if b is negative, we have a reflection across the x-axis. So that is everything. And in fact, we can note that cosine follows the exact same pattern. So y equals a cosine of bx minus d and quantity plus c. So all this information works equally for cosine. We're just not going to go through the demonstration. We're just going to note it is the same. You can work it out. And with that, we are now ready to talk about practicing how to do these graphs transformations when we have multiple transformations involved. Oh, I just remembered I forgot to talk about where the midline is. So we need to remember that the midline is going to be at y equals c. Alright, so now with that, I think we got everything. Let's see, shifts up, down, amplitude, period, midline, reflections. I think that's going to do it. Alright, thank you for watching this video, or this episode of Math with Haas. If you've been enjoying our content, please subscribe, consider supporting us on Patreon. Thank you for your time and joining our math party. We will see you next time.